Solving polynomial equations using technology. So earlier we saw linear equations and quadratic equations. Those are the types of polynomial equations. And we're going to use that idea to solve more polynomial equations, like a cubic equation, a quartic equation. But the key thing with all these, mentioned before, the highest power, which gets you the name of the polynomial equation, is also, it's called the degree of the polynomial equation, but it's also the number of solutions you have. So a quartic equation should have 4 solutions. A cubic should have 3, quadratic should have 2, and linear should have 1. Whatever the highest power is in a polynomial equation, that's how many solutions you should have. Now we're going to use technology to solve this. And very simply is that the way we're going to solve it is we're going to graph it. We're going to put one of these under y1, one of these under y2, and we're going to find intersections. So I'm going to bring out my calculator. I'm going to go y equals. So we have 2x squared plus 4. And 7. Now sometimes you gotta fix the window, make sure you see things, but then we're gonna hit graph. Now I have it on zoom standard, so hopefully I can see things from here. And right there, right, I have this graph. By the way, when you solve this little question on test, you generally want to show the pictures, just let them know how you're solving it. Right, my solutions are gonna be here and here. So how do I find those crossing points? Well, we're gonna go to calculate, it's in blue here. So we're gonna calculate things. And then we're going to find the intersection, number 5. Now all you want to do is move around until you get close to the intersection. You don't have to be right on it, but you just want to be close to it. Then you hit enter and it says, okay, is that the first curve? Then it jumps to the second curve. Right now it's on the line, like that's what it's on. I was on the parabola, but now I'm on the line. And you generally don't want to do anything. You just want to go, okay, yeah, that's the second curve. Just make sure it's that one. Guess, so lets the calculator, like, no, yes, you want the calculator to guess, like, do the mathematics to figure it out. And I get this. Now, most of the time in IB, it's 3 sig figs. So keep in mind the intersection is the x value. When does it intersect? So we're going to do 3 sig figs here. For this one, that is x equals negative 1.22. And then to find the other one, we're just going to have to go back to calculate. Go to intersect. Move it around. Now, sometimes it's actually easier to move it on the second graph. If you press up or down, you switch graphs. And I think the straight line is a little easier to move. You just want to get close to it. Hit enter. Then it's to jump down to the parabola, like that, your second graph, and you yeah, enter, and then guess, yes. And I get this point is 1.22. So that's how you solve using technology. I guess, again, so it was a quadratic, I got 2 solutions, there we go. The next one, I'll do the exact same thing. Go up here, let's write x cubed. Right, so to write a cube, I had to use a caret because there's no cube shortcut here. Plus 4x squared. And then on the other side, I have 6 minus x. Now, if you really want to, you can move stuff around so it'll still work. You can move these to the other side and simplify, and we'll talk about that. What happens if you do move it around here? But it works either way. A graph like that. And I gotta look, I could still see it. We'll talk about ones where you have to move your graph to like fix your window to see it, but I got lucky, so I could still see it. And you can see there's 3 solutions. There's 1, 2, and 3. Again, I have to show my work. So in this case, that just means showing the picture I'm drawing. Looks something like that. So here, here, and here. Again, I'm not going to do all these because it's going to be to try your own, but you want to find the intersection. And then just get close to one of them, start right far right, hit enter a couple times. And I get 1. Ooh, nice. Right here. I don't get the other ones. Intersect. That's close enough to the next one. You get negative 2. I should put my answer over here. X equals 1, negative 2, and last one, intersect. Over there somewhere. Hit enter a few times. And negative 3. So again, just showing you how to solve with a calculator. Now, well, how about it equal to 0? There's actually 2 ways to do it. So I'm going to show you both ways to solve it when it happens to equal 0. So let me go to y equals. Let me clear both of these. So the first way to equal 0 is just graph this. So we're just going to graph it like normal, of course. X squared minus 5x plus 6. This is factorable. We can just factor this guy. No, it's not. My mistake. Yes, actually, yes, it is 3 and 2. Anyway, I'm going to graph. And it's a little hard to see. But one way to solve this is just by graphing this, making this y1 and not doing anything else. Is when I go to calculate, I look for the zeros, because my graph looks like this. I'm trying to find these guys, which are also known as zeros, because that's x-intercepts. So that's one way to solve this. Honestly, the easiest way to solve this would be factoring. It's 2 and 3. But one way to solve it is you just graph that guy, and then you just find the zero. So we're going to hit 0. Now 0 works a little differently. This is maybe I want to show it to you. The way the 0 works is you want to go a little, look what it's asking. It wants the left bound. So if I'm looking for the 0, it wants me to bound it on the left. Like it's going to search, it wants a search window. So you want to say, like, hey, this is the farthest left you're going to go. That's your left bound. Right, so like my 0, I always like to go to where the 0 is, and then go a little left of it. So I'm like, okay, that's my left bound. Then it says, what's the right bound? So again, it wants a little search window. So you just go to the right of it and go, like, hey, that's your right bound. So I'm just going to go a little right over my 0. It's kind of hard to see in here because it's so small. But like that. And then it says guess. And what it's going to do when you hit guess is it's going to search within that little window to find the 0. And they find it at 2. Again, I can do that on the other side to get 3. You just go. My 0's right here-ish. Again, really hard to see, but go low left, hit enter, and go back to your 0, and then go low right, hit enter, and then it says guess. It's going to do the exact same thing. It makes a little left bound here. We're going left to right. It makes a little right bound here. And it searches between these two bounds to find your 0, which was 3. That's one way to do it. I'll leave that for there. And I'll show the opposite way for here. I'll show you the other way of doing it on here. So on this one, the exact same question. How do I solve this when equals 0? If you don't like going, I don't want to search for the 0. Well, it's actually very similar to what we did up. It's the same thing we did up there. Just make a y1, y2. So you get x to the 4th, caret 4 because it's going to be higher, minus x to the 3rd, plus 2. And then on my y2, I'll make that 0. Then we hit graph. Well, these don't solve. This well, anyway, you would find the intersection. This actually doesn't have an intersection. As you can see here, it doesn't cross the x-axis anywhere. This is actually no solution, no real solution. That's what happens here. If you don't have any x-intercepts, you have no real solution. So if I try to go so I can calculate intersect, and I press like enter, they're not going to cross. It'll tell you eventually. It's going to tell you that this is no real solutions. See no sign change? No real solutions. So you can't solve using technology. These are all imaginary numbers. Anyway, that's the idea.